Kia ora. In this video, I'm going to look at the locus part of this complex numbers question. Now, if you do a good diagram, it's very easy to get full marks here. It's not a particularly tricky, conceptually tricky question. On a sketch of an argon diagram, show the locus representing complex numbers satisfying this equation. So you should be able to look at that now and go straight away that that's going to be a perpendicular bisector for the locus, and I'll explain why in a second. Once you've found that, then you need to find the complex number represented by the point on that locus where the absolute value, where the modulus of z is the least. In other words, where the distance from 0 to the point is the least. And we have to find the modulus and argument of this complex number going to 2 decimal places. So let's start off by looking at this thing here and thinking about it before we get going. So we've got this. Now we can rewrite that as a point and its distance between the origin and the point being the same as the distance between a point and the point 4 plus 3i. Now I've just about finished marking this question, and a lot of even very strong students have really mucked this up, right? So we always need to get it to be a point here and another point here, and we're looking at the distance between those 2 points. Okay, so if you start off this question by getting it into this form, you can't really go too far wrong, because what we've got to do next is to draw a nice, roughly to scale diagram. So I'm deliberately not doing this all flash in GeoGebra, right, because I want you to see how you'll do it in the exam. So we're looking for the origin, and then we're also looking for the point 4, 3. So I'm going to count out with my ruler. 1, 2, I don't think you can see the ruler on the screen, 2, 3, 4. So that's where my blob's going to go there. 1, 2, 3, 4, and then I'm going to go to scale up here. If you go to scale, it's going to help you with the second part of the question, right? So don't do anything too rough. 1, 2, 3. So about there. Right, we get rid of the ruler and we put a dot here. So we'll call that point B and we'll call this point A. Right, now the first point we know is going to be on that locus is the midpoint of that line segment. Spoiler alert, that turns out to be the point we're looking for in part 2. So the midpoint here is here, call that point C, and that's going to be at coordinates 2 and 3 over 2, right? Because this is at point 4, 3. Now this is doing it in coordinate form, not in complex numbers form, but it's the same thing. So the perpendicular bisector is going to be the line that's going through here. And you can see that if you've got this point here at A and this point here at B, then C is equidistant between those 2 points, but so is this point here, right? We've done that in class. I feel like we've done quite a lot of those examples this year now. Okay, so anywhere on that perpendicular bisector is going to give me equal distance from the point to A and to point B. What we have to do now is to find the equation of that line. Now, if you were doing this for NCEA level 3, I'd be wanting you to start by substituting in x plus iy. But in the A-level exam, it's fine to recognize that it's going to be a perpendicular bisector by the structure of the question. Okay, and we can say that we're looking for the perpendicular bisector of 0 plus 0i and 4 plus 3i. And again, I saw a lot of diagrams with this point down here, with a point down here, or sometimes even a point down here, right? So that's not what we're looking at. The midpoint will be 2, 3 over 2 is on the line. And we know that MAB, the gradient of that little line, is going to be 3 over 4. So our M will be negative 4 over 3. That means that the equation we're after will have the equation will be negative 4 over 3x plus c. And then the last thing I need to do is to substitute in the point here, giving me 3 over 2 is equal to negative 4 over 3 times 2 plus c. So 3 over 2 plus 8 over 3 is equal to C. Now you guys can grab out your calculators, but I'll just do it the slow way. So 3 3s are 9 and 8 2s are 16. So not a particularly nice number, but there you go. We get y is equal to negative 4 over 3x plus 25 over 6. Now go back and have a look at your graph, and let's see if that looks about right. Well, 25 over 6 is a wee bit more than 4, so that looks exactly how it should be. And if you've done to scale, you can check that really accurately. I don't like leaving it like that. I'm going to shove everything into a common denominator. I'm going to times through by 6. I'll get 6y is equal to negative 8x plus 25. And then that gives me 8x plus 6y is equal to 25. Now that's the standard way that you'll find that written in the Cambridge schedules. It is completely fine to leave it in that form unless you've been asked for it in the form ax plus by equals c. All right, so that's the first part of the question done, and that was worth 3 marks, 2 marks. And that feels about right, because really the skills in there are pretty much ones from AS. The second part is, I think, quite generous in some ways, because all you're asked to do is to find the complex number represented by the point on the locus where the distance from the origin is the least. So let's go back to our diagram. And I'm going to take my ruler, just in case any of you have forgotten this. We're going to look at which point on that locus is going to have the lowest distance from the origin. So if you're stuck and you're doing this, you can just about see what's going to happen, right? So here, we start up at this point on the y-axis. Well, the distance is big, right? And then as I start to tip, the distance is getting smaller. And look, it's getting smaller when I'm at a right angle, right? So we know that the shortest distance from a point to a line is where it is. If this is the line I'm trying to get to, the shortest distance from that point will be where it's perpendicular. But by the way we've constructed it, that point is the midpoint. So that's what we're after. So we'll get rid of that ruler and we'll go down here and write something up. So something like this: shortest distance is where, okay, sorry, got interrupted. So after that interruption, we'll back into it. So the shortest distance is where the line, let's write that again. Sorry guys, words are not coming out very well. The shortest distance from the locus to the origin is where the line segment is perpendicular to the locus, i.e. at 2 plus 3 over 2i. So this is what we're looking for. Now we just have to find the modulus of that, which will be 4 plus 9 over 4, which is 25 over 4, square rooted, which is 5 over 2. And the angle from here to here we're in the first quadrant, so it's just tan inverse of 1.5 over 2, which is 0.64, or 36 point, I think we were asked to go to 2 decimal places, so 36.87 degrees to 2 dp. Okay, so I know this has been kind of a slow and rambly video, but I've kind of done it like that on purpose because I really want you guys understanding what's going on with this. We've got a perpendicular bisector problem, and we're going to get that easily if we draw a good graph. And the second part is just using a coordinate geometry fact and then applying a little bit of basic complex numbers stuff. So again, a really, really great problem. This will come up in level 3 calc as well. It's probably at kind of a high merit level for a level 3 calc question. Thanks for watching.